Okay, what we have here is a ramp. Ball can come down the ramp and off of this ramp, and then it'll go off the edge and down onto this wood block here. On top of the wood block we have a piece of white paper, and on top of the piece of white paper a piece of carbon paper. The white paper is butted up against the leg of the table here, and that's going to go back here and see the ramp. Okay. The leg of the table is going to give us a constant point of reference. We've checked the plumbness of the table leg using a level and find that it's not very far off of level, not far enough to interfere with the results of this experiment. But what I'm going to do is I'm going to release the ball from a specific point on the ramp. It's going to come down the first ramp and onto the second and off of the second, and it's going to land on the carbon paper, which is on top of the white paper, which is on top of the wood block. And it's going to make a mark on the carbon paper. Now you notice that the block is sitting on top of a bunch of booklets. After we see how far the ball goes, excuse me, as it comes off the ramp here, we're going to remove some booklets so it has a greater distance to fall. And then we're going to see how far it goes if it gets to fall that greater distance. And we're going to keep removing booklets until we get down to the chair here. I think you can see the chair maybe. And we're going to use that information along with our knowledge of how far the ball fell to determine first the time it takes the ball to fall, given the acceleration of gravity, which we've measured using the pendulum. So that for each height, for example, the first ball is going to be about 6 centimeters. The second will probably be about 12, the third about 24. And we'll probably do about 3, okay? A 6 centimeter fall, a 12 centimeter fall roughly, and roughly 24 centimeter fall. From the distance the ball falls, we can determine its the time of fall. And then from the horizontal distance the ball travels, we can determine its horizontal velocity. Determining the horizontal velocity for each of the 3 falls, we're going to be able to test whether the horizontal velocity changes as the distance of fall changes. Okay? So, first run, here we go. Simple enough. You might be able to say, I don't want to move the paper, but we have a nice distinct mark where the ball hit. We're going to do one more run at that distance, and the ball hit right on top of the last mark. Okay, I didn't catch the ball that time, had to retrieve it. Now, we're going to remove about, let's say, another 6 centimeters worth of booklets. That'll bring us down to about this level. Let's see our distance. Yeah, that ought to be pretty good. So let's put the wood block down here. We're going to butt the paper against the leg. Let me comment. Let me show you the paper since you have it. Let me move in a little closer. Okay, hopefully you can see the dot here. Actually 2 dots, one right on top of the other. And there's a mark here. That mark is right at the edge, was made right at the edge of the table. That mark is synchronous with the edge of the table, which is the point at which the ball leaves the ramp. Okay, so let's go ahead and set the system up, and let's release the ball. Okay. Release it once more. And we see there's another mark, really a double mark. And now, let's just remove the rest of the booklets. Oh, wait. I need to measure. Okay, that distance was about 13.3 centimeters. Now, let's just put the apparatus down here and measure the height. The height is now about 29.7 centimeters. So let's see what kind of distance we get this time. Okay, so let's make sure that we're hitting. Yeah, we hit on the paper, so everything's fine. One more bad hop, but I'll retrieve the ball later. Okay, so we see now the first mark, well, the mark that indicates the horizontal position of the ball when it left the ramp, the mark that indicates the horizontal position or the horizontal distance the ball traveled on the 6 centimeter fall, the distance on the 13 centimeter fall, and the distance on the 29 centimeter fall. Now I note that the mark for the 13 centimeter fall is not as distinct as I'd like it to be, and it seems to be a little bit off center, and I'm not sure why that is, but let's just go ahead and set the books up for the 13 centimeter fall once more. And see what happens if we repeat the experiment. Or at least we repeat the trial for the 13 centimeter fall. Now this pretty well confirms what we saw before. We see that the new mark is just about in the same position as the old mark. Now I'm going to give you a nice close-up of this paper, and I'm going to put a meter stick across the paper. I'll actually put 2 meter sticks across the paper because with the video camera you're not going to have very good parallax. You can't see what I'm talking about, but you will in a minute. Okay, now there is the paper. We're going to need to zoom backwards just a little bit. Let's reposition the camera slightly. And then let's move in. So you can get a good reading of these distances. Here's the position where the ball left the ramp. Here's the horizontal position where the ball hit after 6 centimeter fall. Here's the position after 13 centimeter fall. Here's the position after I believe it was 29.7 centimeter fall. You should have written that down so that if I've got the distances a little bit wrong, you can compensate.